First thing which I learned in linear algebra was filling of space. A space could have R2 entries, which is a two-dimensional space, a three-dimensional space having R3 entries, and an n-dimensional space with Rn entries. If we consider vectors like for R2, 1 or 2 vectors, the span of it, the span of it is how we fill that space. Similarly for R3, we have same vectors spanning around will fill up space. So the core concept is we have vectors. How is its linear combination going to fill the space? For R2, if we have one vector, it will be a straight line. That's the only space it can fill. For but if we have two vectors which are linearly independent, it can fill the entire space. In here, linearly dependent just means they should be for two vectors. I can say the other should not be a multiple of one vector. But when there are three vectors, especially in R2, then the other vector would obviously be a linear combination of two independent vectors. The sum of the two linearly independent vectors in R2 would obviously always give any another kind of vector present in that space. For R3 space, on the other hand, one vector will always form a line, two vector, if they are linearly independent, they would form a space. Sorry, not a space, they would form a plane. If they are dependent, then they will again form a line. But if that two vector cannot fill the entire R3 space, so we need a third linearly dependent vector. Sorry, make so much mistakes. A third linearly independent vectors. These three independent vectors can fill up the entire R3 space. Same goes for any space. If we have n independent vectors, we can fill up that entire n dimensional space. Rest other vectors could be there, uh, but automatically in a certain space, n, any extra vector than the n will be dependent on that n vectors if that n vectors are independent. Thank you.